I'd like to now look at some examples of solving trig equations by using identities. For example, this problem asks us to solve sine of 2 theta equals cosine of theta on the interval from 0 to 2 pi. Well, there's two problems with this particular equation. Problem number one is it involves two different trig functions. It involves sine and it involves cosine. We can't solve a trig equation unless we change all of our functions into the same trig equation, or trig function. The second problem is we have different angles in this particular problem. We have a 2 theta, a double angle, and we have a single angle. We must have all of the same angle if we're going to solve a trig equation. The first thing we're going to do is we're going to actually notice that the left-hand side that involves the double angle can be rewritten using an identity that we've learned from an earlier lesson. Sine of 2 theta using an identity is equal to 2 times sine of theta times cosine of theta. So we're going to use that substitution and substitute that expression for the sine of 2 theta. Okay, that's still equal to cosine of theta on the right. Now we've solved one of our problems. One of our problems was that we had a double angle along with a single angle, and now you can see that we only have single angles. From here, what I can actually do is I can subtract the cosine function over to the left-hand side, and even though I can't combine any of the terms, I can rewrite it, and I can say that this is 2 sine of theta cosine of theta minus a cosine of theta. And then we notice that the two left-hand terms have a cosine of theta in common. What's going to happen from here is I can actually factor out that common cosine factor. So I'll have a cosine of theta on the outside, and then on the inside I have 2 sine of theta minus 1 equals 0. I haven't solved the problem of there's two trig functions contained within my equation. However, in this particular case, by factoring, my outside factor has only one trig function in it, and when I set this equal to 0, that equation only contains one trig function. And then over here, where I set this equation equal to 0, that one in itself only contains one trig function. So, in a way, we've solved both of our problems. Let's go ahead and finish solving this equation. Okay, cosine of theta equals 0. And put 0 over 1, and I know that's the ratio of x over r. R being equal to 1 indicates that it's a quadrantal angle. All right. Where is x equal to 0 and r equal to 1? Well, there actually happens to be two locations for that. R is equal to 1 along the positive y-axis, and at that particular point you have 0 and positive 1. Same thing down below. R is equal to 1, the x value is 0, the y value is negative 1. So in this case, we're going to get that theta 1 is equal to pi over 2, and then theta 2 is equal 3 pi over 2. There are two of our solutions. For the other equation, we need to do a little bit of work on it first. I need to add over 1. So I'll have 2 sine of theta equals 1. Divide out the 2. Then I have sine of theta equals 1/2. Well, that's the ratio of y over r. In which quadrants is y positive? Okay, r will always be positive, so that's not a problem. Well, y is positive in quadrants 1 and quadrants 2. All right, so let's draw our picture here. Y is 1, r is 2. And we can see that this indicates that we have a special triangle. The other side is square root of 3 and negative square root of 3. So we're going to have two different answers in here. This I'm going to call theta 3, and then the answer from here around, I'll call that theta 4. Theta 3, I can see that this is a 30-degree reference angle, so theta 3 is going to be pi over 6. And then theta 4 also is a 30-degree reference angle, but in quadrant 2, and so this would be 5 pi over 6. So for this particular problem, I have 4 separate answers, 2 coming from one factor and 2 coming from the other factor. This concludes this lesson on solving trig equations by using identities.